Hi, welcome back to Moose and Chemistry. We're going to look at some loose structure problems today. The first one we're going to look at is, of course, C2H2. All right, so now, again, what you do is you take your C. You've got two of these this time. This is 2 times 4 electrons. And then we'll look at our H's. This is H2 times 1 electron. All right, so far so easy. It's kind of like nothing new. This gives me 8 electrons, and this gives me 2 electrons, which gives me a total of 10 electrons. All right, now remember that C is in group 14, and then we get rid of that 1 there, of course, and that gives us a total of 4 docking ports. And of course, H is in group, whoops, let's make that a little bit better there. I love messing up. Whoops, no I don't actually. I can use this eraser here. There you go, Mr. Eraser. Okay, so H is in group 1, and of course it has 1 docking port. All right, now, obviously C is our center core atom, but we don't have 1 of them. We have 2 of these guys. So that's kind of really important, okay? So let's take care of that real quickly. Okay, now, so what we're going to do is we're going to do this. We're going to go, okay, C, and then C. Now, we're going to go, remember that the C has here, you have a C and a C here, right? So you got a dot here, and you got a dot there, and you got a dot there, 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 and you have a dot there. Because you have 2 of the C's, right? So this first 2 dots right here is going to make a bond. So that's going to give us a center bond right there. These 2 dots right here are going to come down just like that to give us our second bond there. These 2 dots are going to come up here to give us our third bond. Now, what about these 2 dots here? Well, this is going to make the hydrogen here and make the hydrogen there. So now, let's check to see if this is the best possible structure. To do that, we're going to use formal charge. Remember, formal charge are valence electrons. Right, valence electrons, get that there, minus non-bonding electrons, of course, minus bonding electron pairs. All right, so let's go ahead and do the formal charge for C. So we put the formal charge for C, and we're going to go, C came in with 4 valence electrons because it's in group 14, remember that? Okay, minus non-bonding electrons. Well, they're all being bonded, right? And how many bonds do we have? Let's count them. 1, 2, 3, 4. So we have 4 bonding pairs, and that gives us 0. And that looks really, really good. Now, let's do the formal charge for hydrogen. We don't have to do them both because they both look the same. So the formal charge for hydrogen is going to be 1 electron coming in. There are no bonding electrons left over, and non-bonding that is, and there's 1 bonded pair. And so that gives us a 0. So guess what? That's perfect. We know that we did this one absolutely right. Okay, so let's take a moment here and let me play, hey, let's move the eraser around, and we're going to erase this guy's up here. We're going to do a second problem. So again, remember, it's really important to follow all the steps. Because if you leave a step out, you can make mistakes. And mistakes is something that we try not to make. Although, you know what? Just like that stupid eraser ran out on me, I guess it's timed or something. It's got to be timed. All right, so let's go hurry get this here real quickly so we don't run out of our timed eraser. All right, let's do another problem. Let's do this one here. Let's do NH3. Well, N is in group 15, so it's 1 times 5 electrons, and H is 3 times 1 electron. Remember that N is in group 15, so it's going to have 5 valence electrons. Right? We'll get rid of that 1 there because we don't need it. And of course, hydrogen is in group 1, and it only has 1 valence electron. All right, so now let's set this up here. So we're going to put our N in the middle, obviously. There's our closed docking port, so we're going to put in our hydrogens here, here, and here. Well, is this the best possible structure? Well, let's see. Again, we're going to use formal charge, and we know that it's valence electrons minus non-bonding electrons minus bonding electron pairs. Okay, so the formal charge for nitrogen. Nitrogen came with 5 valence electrons. See that right there? That goes to that there. Minus the non-bonding pair. Well, we have one non-bonding set of electrons, so that's 2. And how many bonds do we have? We have 1, 2, and 3. Minus 3. Okay, see that? All right, let me go ahead and undo something here real quickly, if I can. I don't know what to kind of skirt around it a little bit there. Okay, come around here one more time. Yep. Oh, it's so... Okay, got it. All right, now let's do one of the hydrogens. All the hydrogens look the same, so all we have to do is just do one of them. So let's go ahead and do that. So hydrogen comes with 1 valence electron, like that there. Okay, minus, there are no non-bonding electrons. They're all being bonded, minus 1 bonding pair. That gives me a 0. And you know what? This is a perfect structure. Pretty darn snarly. All right, let's do one more just in case you were wanted to have some more fun here. This one's going to be a little bit different. This is going to be using a radical. All right, so give me one moment here while I clean this all up for you. All right. So the next one is going to be So4 minus 2. All right, so sulfur is in group 16, so she gets 6 electrons. Oxygen is also in group 16, but there are 4 of them, so it's 4 times 6 electrons. So this is going to give me 6 electrons plus 24 electrons. But look, we have a minus 2 charge. Because of that, we have to add 2 more electrons. So that'll give me a total of 32 electrons. Okay, so let's look here. Let's get rid of that there real quickly. All right, so now our S. Now, you notice that S has 6 valence electrons. Hey, so does oxygen. So which one's going to be our core atom? Well, there's a kind of way to look at it. First of all, when we talk about the core atom, we're talking about, hey, which one has the most docking ports? Well, obviously, they both have the same amount of docking ports, which are 2. But which one is least electronegative? Well, oxygen is more electronegative than sulfur. And you would have to check on your chart to see that. So our sulfur is going to be our core. But look, also we have 4. So watch this. We're going to put our S in this. Whoops, that's an ugly looking S. Wow. Hang on for a second. Let's do this better. So let's put our S in the center here. Let's put our oxygen here, oxygen here, oxygen here, oxygen here, right? So you're going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 32. Okay, guess what? Is that the best possible structure? Well, let's look at the formal charge for S. S comes in with 6 valence electrons. It has 0 non-bonding electrons. Okay. And we're going to have 4 bonded pairs. That's going to give me a +2 charge. Well, you know what? Guess what? Not a good idea. We want to have the core to be 0. So we're going to have to do something here. I want to, got to think about it for a second. What could we do to change that? So let's look at this S. So this S, what if we did this? Let's set this up again. You've seen this one over here, so let's go get rid of that structure. That structure over here is absolutely dead wrong. Goodbye, Mr. Spalding. We're not going to use you because you're not right. All right, now, in this case, let's try this. Let's put a double bond here and a double bond there. We could have put it here or there, but we chose not to. And it doesn't really matter. All right, so we'll put that right there because this is going to be a resonating structure. Now, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. I wonder if this is going to work. All right, so to do that, let's figure out the formal charge. So the formal charge, try this with the S here. Get this pinned right. Why don't you want to write there? Interesting. All right, let's try this. So the formal charge of sulfur. Sulfur comes in with 6 valence electrons, minus there's no non-bonding electrons, and there are 6 bonding pairs. Hey, look at this. Our core atom is now 0. That's what we want. Let's try, we have to do 2 different oxygens here because each oxygen is different. There's 2, so we'd call the first one O1. So we're going to pick this guy right here. We'll start off with this guy right here, okay? Wow, what happened to the dot there? There we go. Do this one. We're going to call that one O1. So oxygen came in with 6 bonding electrons, valence electrons, minus 4 non-bonding electrons. That's these guys right there. Minus 2 bonding pair. Oh, look at that. That's also 0. Hey, snarls. So that's what we want. That's great. Okay, so now let's go ahead and get rid of this arrow here. So that looks good, and I'm going to crash land that arrow. Oops, I took out some of my oxygen there. And let's get some oxygen back there. There we go. Well, it's not beautiful. Let's fix that again. You know me, I gotta make it right. Just my wanting to do things in a nice way. Okay, that looks a lot better. Okay, so now let's do this oxygen right here. I could have picked this one here, but I chose this one here. We're going to do that one. All right, so let's see here. Formal charge for oxygen. We'll call that oxygen 2. Oxygen came with 6 valence electrons. It has 6 non-bonding electrons. You can see those dots there. And it has 1 bonding pair. Oh, look, that's a -1 charge. It's -1 there and -1 there. So guess what? That gives us the -2 charge. So let's clean this up a little bit here. And we have to do something called a radical. So we're going to make the radical here. Okay. So what that means is we basically put this bracket here. And, oh, come on, work with me. Why aren't you writing over there? Maybe it was a dead spot on the screen. Okay, so we bracket it, and we go -2. And that's how you do it. And you guys be snarly. We'll see you back here at Moose in Chemistry, and I hope you enjoyed this exciting lesson.